This was the question presented in the lab of week 6 on our lab 2. We were given a right angle triangle with point P and a portion of the major axis AB, and our tangent to the ellipse is PB, somewhere along PB. And we're given our focal point F1. So this is how I went about solving the question. We know that tangent PB can act as an axis of reflection. So what I did was join P to F1 and reflected F1 up here. So I essentially created an isosceles triangle or two right angle triangles, whichever way you want to look at it. Once I reflected F1, I knew that somewhere along the major axis F2 had to be somewhere along this line. So what I did was, at the same angle as P to this point here, I just brought a line back down, and where that cut the major axis, that was where F2 was. From there we were able to find our major auxiliary circle, because we know that from F2 to P and P to F1, the sum of those two lines equals the length of the major axis. So then I found the center between F2 and F1 to find where the major or the minor axis is, and just drew my major auxiliary circle. Then to find our minor auxiliary circle, we know that if we go from point P parallel to the minor axis to hit our major circle and join it back to the center, and then we go parallel to the major axis from point P, that will give us a point on our major auxiliary circle. So from the center I described a circle all around, and that gave us our minor auxiliary circle, and then just use the ellipse function to draw our ellipse, and the black lines are our finished solution. And that was how I solved the question.